The sun burns at 27 million degrees Fahrenheit at its core. Let that sink in. Now zoom out. There are an estimated 2 trillion galaxies in the observable universe, each packed with hundreds of billions of stars. Look up at the night sky. What you're seeing isn't darkness. It's a sky lit by more fires. Then there are grains of sand on every beach on Earth, combined. So here's the question. Why? In the middle of all that fire, is space almost unimaginably cold? The sun alone releases 384 septillion watts of energy every single second, and yet, just a few hundred miles above your head, space sits at minus 455 degrees Fahrenheit. Almost absolute zero, the most powerful furnace in the solar system. And the space around it, basically frozen. That sounds like a contradiction, but it's not. To understand this, we need to fix something fundamental. What temperature actually is. We say hot, we say cold, we feel it every day. But temperature is not a property of empty space. It's a property of matter. Temperature measures how fast particles are moving, how violently they vibrate. A hot object, particles shaking wildly. A cold object, particles barely moving. And the coldest possible state, absolute zero. Minus 459 degrees Fahrenheit, where motion nearly stops. But here's the key. If there are no particles, there is no temperature. You can't measure the temperature of nothing. And space, it's not completely empty, but it comes terrifyingly close. In the vast voids between stars, you'll find about 1 atom per cubic meter. On Earth, that same space holds 25 quintillion molecules. That's a 25 with 18 zeros behind it. That difference, that's the answer. Heat travels in 3 ways, and each one explains why space is so cold. First, conduction. Touch a hot pan. Heat flows directly into your hand, particle to particle, energy passing through contact. But in space, nothing is touching. So conduction, impossible. Second, convection. Boil water, hot rises, cold sinks, heat circulates. But that needs a medium, air, water, gas. Space has none. So convection, also gone. That leaves only one thing: radiation, energy, traveling as waves, through pure emptiness at the speed of light. This is how sunlight reaches Earth across 93 million miles of vacuum. But here's the twist. Radiation does not heat the space it travels through. It only heats what it hits. The sun is blasting energy in every direction, constantly. But space itself doesn't absorb it. It just lets it pass. Silently, endlessly, only when that energy strikes something, a planet, a spaceship, even a grain of dust. That's when heat appears. So space isn't cold because the sun is far away. Space is cold because there's almost nothing there. Now here's where it gets strange. If space is cold, why do spacecraft overheat? Why do astronauts need cooling systems? Not just heaters? Because space doesn't give you one temperature. It gives you extremes at the same time. In direct sunlight, temperatures can hit 250 degrees Fahrenheit. Take one step into shadow, and it drops to minus 250. No atmosphere, no buffer, just instant, violent contrast. And that's the reality of space. Not just cold, but brutal extremes. And maybe the real question isn't why space is cold, but how, in a universe this cold, warmth like ours was ever possible at all.